ID, the Future, a podcast about evolution and intelligent design.
Hello, I'm Tom Gilson. Today on ID the Future, we have opportunity to sit in on a key moment in the growth of intelligent design. It's the launch event for the Intelligent Design Center of Italy, which took place in June 2022 in Turin, Italy. It's an historic moment in many ways, another sign of increasing interest in design theory around the globe. We'll be listening in here as John West, Managing Director of Discovery Institute's Center for Science and Culture, puts it in context of the long sweep of history, the design controversy, past and present, including key moments that took place right where they were meeting in Turin. I think you'll find it encouraging.
I am honored to be able to join you today for this inaugural event of the Italian Center for Intelligent Design. This is the first occasion my wife, Sonia, and myself have been able to be in Italy, yet as members of the wider, Western civilization, I think anyone who lives in the West cannot but feel connected to Italy. It is a joy to be in the country of Dante, Da Vinci, Michelangelo, Clementi, Cicero, and so many others who helped form our civilization. And so it's actually humbling to be here. I'm going to be speaking about the importance of intelligent design to both science and society. But first, I'd like to share just something briefly about who we are at Discovery Institute and about the growing network of scientists and other scholars who see evidence of purpose in nature. Discovery Institute is a nonprofit and non-governmental organization focused on research and education. It's based in the city of Seattle in the United States. As Marco already described, it was founded in 1991, and its Center for Science and Culture was founded in 1996 by philosopher of science Stephen Meyer and myself. And our mission, as was already described, is to advance the understanding that human beings and nature are the result of intelligent design rather than a blind and undirected process. And some of the things that we do, we support science research, sponsor educational programs, and then are involved in publishing of books and articles and educational videos and documentaries. We have more than 45 research fellows directly affiliated with us. Here's just a fraction of them, drawn from such disciplines as molecular and cell biology, genetics, paleontology, microbiology, chemistry, biochemistry, physics and astronomy, mathematics, and more. And we'd like to think that we are building on what we're doing on a great tradition of human thought. Because questions about whether nature was produced by mind and artistry or by a mindless material process reaches back to the roots of civilization. It's one of the truly great questions in the history of humanity. Many different thinkers across time have recognized that nature displays clear evidence of design and purpose in nature. These thinkers have come from many different traditions: Greek, Roman, Jewish, Christian, Islamic. In 45 BC, one of my favorite authors in the Roman tradition, Roman statesman and philosopher Cicero, wrote his dialogue De Natura Deorum, and in book 2 of that dialogue contains an extensive discussion of the Stoic view of nature. And according to one of the characters of Cicero's dialogue, we should deny the name of human being to anyone who sees the regularities of nature, but then asserts that nature is just the product of chance rather than reason. Cicero believes that such a person shouldn't even be regarded as a human being. And as he wrote this, when we see something moved by machinery, this is Cicero writing, like an orrery or a clock or many other such things, we do not doubt that these contrivances are the work of reason. So therefore, when we behold the whole compass of the heavens moving with revolutions of marvelous velocity and executing with perfect regularity the annual changes of the seasons, how can we doubt? How can we doubt that all this is affected not merely by reason, but by a reason that is transcendent and divine? Cicero then adds this: can any sane person believe that all this array of stars and this vast celestial adornment could have been created out of atoms rushing to and fro fortuitously and at random? Or could any other being devoid of intelligence and reason have created them? Not merely did their creation postulate intelligence, but it is impossible to understand their nature without intelligence of a high order. To come now from things celestial down to things terrestrial, which is there among these latter, terrestrial things? And then he ends up talking about animals and plants and their adaptations to their environment. Which is there among these things, among animals and plants, which does not clearly display the rational design of an intelligent being? Cicero's dialogue from 45 BC gives just a taste of how central a belief in intelligent design was to many thinkers in the history of our civilization. But intelligent design wasn't just central to the development of Western civilization in general. It also supplied a foundation for modern science in particular. Early scientists thought they could unravel the mysteries of nature because they believed nature was the product of an intelligent designer rather than an accidental process. It's because early scientists thought nature was the product of intelligent design that they expected nature to be orderly, purposeful, governed by laws rather than chaos, and understandable through human reason. We're so used to this that we just think, oh yeah, of course you'd believe that. But that's not what in the pre-Christian West many people believed. Many people believed things were just disorderly, chaotic. This idea that you think nature reflects the intelligent design of a designer is because, again, the scientists thought that nature was the product of intelligent design, that they expected nature to be orderly and purposeful, and that they could understand it through science. In the words of British writer C.S. Lewis, who was already alluded to in my introduction, men became scientific because they expected law in nature. And they expected law in nature because they believed in a legislator. Now that's historically speaking. But I'd like to point out that even today, scientific investigation proceeds because scientists assume for the sake of their research that what they are studying is orderly and reflects some rational purpose. In other words, scientists have to treat what they are studying as if it was intelligently designed in order to hope to understand it. So when scientists look at a molecular machine like the ATP synthase, which is sometimes known as the power plant of the cell that helps produce the energy that allows us to be here breathing and existing, or when they look at the walking kinesin motor, the molecular machine also inside our cells that transports molecular cargo inside our cells, or when they look at the bacterial flagellum, this outboard motor that helps bacteria move. When scientists study these amazing molecular machines, they treat them as systems where all the pieces work together for a purpose. In other words, they treat them as if they were engineered, as if they were designed. That's why they think they could understand them. If they thought they were just chaotic assemblages of accidental things, they wouldn't actually treat it as a system that they could understand all the parts and all the parts mean something. This is the essence of much of scientific investigation today. We treat things as designed so we can understand them. And that's why intelligent design is not a science stopper, it's a science starter. It's actually the precondition for being able to do science. And I came to appreciate this truth many years ago in a discussion with a professor of microbiology at an American research university. This professor told me how he was attracted to the idea that nature displays evidence of intelligent design because he found it much more consistent with how he actually pursued science in his lab. As he described to me, he said, that to understand how a certain biological system works, he and his colleagues would assume that that biological system under study was designed to fulfill a particular purpose. They further assume that each of the parts of the system plays some sort of helpful role in achieving that system's overall purpose. They did not treat the system they were studying as something cobbled together haphazardly or whose parts may be useless or redundant. In other words, these scientists treated the biological systems they were studying as if they were intelligently designed, and that assumption of design guided their investigations in the lab. The reality is that intelligent design is a guiding assumption for scientific research, even for those scientists who claim not to believe in it. Unfortunately, during the past 150 years, this foundational truth on which modern science rests, that nature is understandable because it was designed, has become obscured, largely due to the ideas of British naturalist Charles Darwin. In the 19th century, Darwin claimed that the appearance of design in nature, that scientists can't reject because it's just so obvious, that the appearance of design in nature was actually an illusion produced by an unguided process driven by random and accidental variations in nature. In Darwin's own words, there seems to be no more design in the variability of organic beings and in the action of natural selection than in the course which the wind blows. Darwin's idea that nature is the product of an unguided process that mimics design, that what brought us all about was through an unguided, haphazard process that did not have us in mind. That idea has had serious negative consequences for both science and for society. In the area of science, Darwin's theory has repeatedly held back science by encouraging scientists to dismiss anything they can't understand initially as useless leftovers of the blind evolutionary process. In his book, The Discarded Image, C.S. Lewis wrote that nature gives most of her evidence in answer to the questions we ask her. I think that comment is profound. The answers we receive from nature are dictated by the questions we ask, and the questions we ask are shaped by the assumptions and expectations of the scientific theories we embrace. If we assume that nature is the product of blind and accidental causes, that is going to shape the questions we seek to ask nature, and those questions will limit what we actually discover. Nowhere is this more true than in the field of Darwinian evolution itself, which is based on this inviolable assumption that everything in biology must be the result of unguided material causes. Over the past century and a half, this assumption has undoubtedly inspired many interesting research questions and scientific advances, but at the same time, it has also undoubtedly discouraged and delayed many other important research questions. Witness the unhelpful Darwinian preoccupation with what is often called vestigial organs over the past century. Time and again, biological features we do not fully understand have been dismissed by Darwinian biologists as non-functional leftovers from the blind evolutionary process, or dead ends left over by this blind process. Yet time and again, researchers who eventually bothered to look discovered that such supposedly vestigial features as the appendix and tonsils, to name two, actually perform important biological functions. In the case of tonsils, actually helping fight infections. The evidence of function was there all along, but scientists were discouraged by the existing paradigm of Darwinism from bothering to ask the questions that would elicit the evidence. More recently, as Carlo mentioned at the beginning, one of the biggest blunders in the history of modern biology may turn out to be the belief that the human genome and the genome is riddled with so-called junk DNA. Now, what is this? Well, the idea was that random mutations in protein-coding DNA are supposed to drive Darwinian evolution. So when it was discovered that the vast majority of our DNA does not code for proteins, many leading Darwinian biologists jumped to the conclusion that non-protein coding DNA must be mere junk left over from the evolutionary process, just like some vestigial organs. Because if it doesn't code for proteins, it's not going to help Darwinian evolution move forward. So it must be extraneous, must be a leftover. Not only that, leading evolutionists such as Oxford University's Richard Dawkins championed junk DNA as proof, positive proof, that human beings were the result of an unguided evolutionary process rather than intentional design. However, when scientists finally began to look at what non-protein coding DNA is and what it might do, they were shocked. Reality did not correspond to their Darwinist assumptions. Starting with something called the ENCODE project around 2007, there has been a flood of research showing that so-called junk DNA actually perform important biological functions. In the words of biologist Jonathan Wells, one of my colleagues at Discovery Institute, far from consisting mainly of junk that provides evidence against intelligent design, our genome is increasingly revealing itself to be a multidimensional, integrated system in which non-protein coding DNA performs a wide variety of functions. Again, the evidence of functionality in non-protein coding DNA was always there to find, but the evidence was not forthcoming because few people were asking the right questions because they were blinded by the Darwinian paradigm. Now, Darwinian theory has been bad for science, but its consequences for human culture have been nothing short of disastrous. And I want to just briefly talk about 3 social consequences of Darwinism that stand out. First, in the Darwinian view, humans were devalued as just another animal. In the words of Princeton University bioethicist Peter Singer, all we are doing is catching up with Darwin. He showed that we are simply animals. Humans had imagined we were a separate part of creation, that there was some magical line between us and them. Darwin's theory undermined the foundations of that entire Western way of thinking about the place of our species in the universe. We are just another animal. Second, in the Darwinian view, some humans are regarded as inherently better than others. To be blunt, in the traditional Darwinian view, some humans are not as evolved as others. No continent suffered more under this false view than Africa. Darwinism helped feed European colonialism and imperialism, justifying racist claims that Africans were the closest humans to apes. Darwinian ideology played a key role in the rationalization of one of the first genocides in the 20th century, which took place in southwest Africa in what is modern Namibia. Darwinian ideology also played a role in putting indigenous peoples on public display throughout Europe and the United States in what today are known as human zoos. The humans put on display were often presented to the public as evolutionary missing links between apes and man. And several of these human zoos actually took place in the city we're now in Turin. There were a series of national expositions from the 1880s through the 1920s where they put on ethnographic displays where they put native peoples on display in some of these human zoos. But this was throughout Europe and the United States. The Darwinian ideology underlay those displays. In the area of criminal justice, meanwhile, the same devaluation of some humans being less valuable than others, Darwinism influenced many to view criminals as subhuman animals, One of the most celebrated Darwinian criminologists lived in this very city again. His name was Cesare Lombroso, who was a longtime professor of forensic medicine at the University of Torino. To this day, there is a museum in Torino devoted to his work. I visited it this morning. It's a very interesting museum. Lombroso and his followers stigmatized some people as what they called born criminals, viewing them as subhuman throwbacks to an earlier stage in evolutionary history. And so you were committing crimes because you were actually a throwback to an earlier evolved form. Lombroso and his followers further denied that criminals were moral agents who were responsible for their actions. And again, Darwinian theory fed their views. Now, third and finally, as the social impact of Darwinism, I think, would be the idea that humans are devalued because we're portrayed by Darwinian theory as a cosmic accident. In the words of Harvard paleontologist George Gaylord Simpson, man is the result of a purposeless and natural process that did not have him in mind. Consider the striking difference between Simpson's view and the view expressed by the former Pope Benedict in 2005. According to Benedict, we are not some casual and meaningless product of evolution. Each of us is the result of a thought of God. Each of us is willed. Each of us is loved. Each of us is necessary. Benedict's view, I would say, is sublime, a view that leads to purpose and meaning, while Darwin's view often leads to despair. It's a sad fact of Darwin's own life that his embrace of unguided evolution paralleled his own loss of wonder and appreciation for the natural world and beauty. When Darwin was 22, he walked in the midst of a Brazilian rainforest, and he writes about this near the end of his life. Confronted by the beauty, he experienced an overwhelming sense of awe. This was when he was a young man, before he developed his theory. Surely, he thought, man was more than a mere animal, and there was some greater purpose behind nature than mere physical survival. Unfortunately, Darwin's sense of awe did not last. Fast forward to the ending part of his life. As he wrote in his autobiography before his death, reflecting on his earlier sense of awe when he was in that Brazilian rainforest, Darwin wrote that now, not even the grandest scenes in nature would inspire such a view. Why? Well, he explained that the evidence of exquisite design and purpose he once saw in nature failed now that he had discovered his law of natural selection. The older Darwin also lost his appreciation for poetry, paintings, even music. Again, as he wrote in his autobiography, a very sad passage, "Now for many years I cannot endure to read a line of poetry. I have also almost lost any taste for pictures or music." Imagine a life without paintings or music or poetry. "I have also almost lost any taste for pictures or music. I retain some taste," this is again Darwin, "for fine scenery, but even that," he said, "does not cause me the exquisite delight which it formerly did. My mind seems to have become a kind of machine for grinding general laws out of a large collection of facts." What a tragic result. Not just for Darwin, but for those shaped by him. Now, for the rest of my talk, I want to shift because that is tragic. But I'd say the good news is that science over the past decades has shown that Darwinian theory is not sufficient to explain the wonders we see throughout the natural world. Darwin's mechanism may explain small variations within species, but haphazard evolutionary processes don't seem capable of explaining, as we've already heard in our prior talks, the major innovations in the history of life. And a growing number of scientists are recognizing this truth. If you want to see who some of them are, go to the website descentfromdarwin.org, where you can download a list of more than 1,000 PhD scientists and professors who are publicly willing to state their skepticism of modern Darwinian theory. One of the early signers of the statement was a distinguished Italian scientist who I had occasion to meet before his death, Giuseppe Sermonti, a longtime professor of genetics at the University of Perugia. Sermonti criticized Darwinism as what he called the politically correct of science. Now, many people don't realize it yet, but skepticism of traditional Darwinian theory has spread far and wide among scientists in recent decades. And I'm just going to go through a few examples. Robert Laughlin is a physicist at Stanford University. He is a Nobel Prize-winning physicist. He has gone so far as to declare evolution by natural selection has lately come to function more as an anti-theory, called upon to cover up embarrassing experimental shortcomings and legitimize findings that are at best questionable and at worst not even wrong. Philip Skell was a member of the National Academy of Sciences in the United States, a professor of chemistry at Penn State University, a large research university in the United States. He declared that Darwinian evolution has functioned more as a philosophical belief system than as a testable scientific hypothesis. This quasi-religious function of the theory is why many scientists make public statements about the theory that they would not defend privately to other scientists. Russell Carlson is Emeritus Professor of Biochemistry and Molecular Biology at the University of Georgia, again, one of America's top research universities. He says, science needs to be guided by an objective evaluation of the evidence, and scientists should not allow their thinking to be arbitrarily restricted by dogmatic ideas. We need scientists who think outside the Darwinian box. And then we have David Gelernter, professor of computer science at Yale University. He is known for his breakthroughs in parallel computing. He's widely credited with foreseeing the World Wide Web and the internet. He's one of the inspirations for the programming language Java. In 2019, he announced that he no longer accepts Darwinian evolution to explain the major innovations in life. As he wrote, like so many others, I grew up with Darwin's theory and had always believed it was true. Yet there are many reasons to doubt whether Darwin can answer the hard questions and explain the big picture, not the fine-tuning of existing species, but the emergence of new ones. The origin of species is exactly what Darwin cannot explain. But it's not just individual scientists who are raising questions about traditional Darwinian theory. The Royal Society in the United Kingdom is one of the world's preeminent scientific societies. Its members have included Sir Isaac Newton and more recently Francis Crick, the co-discoverer of the structure of DNA. In 2016, it convened a conference to try to find a new theory of evolution because traditional Darwinian theory was failing to explain the major changes in the history of life. And in fact, Gunter Beckley attended that conference. But it's not only that more scientists are questioning traditional Darwinism, a growing number have embraced intelligent design. Charles Townes was another Nobel Prize-winning physicist. He was a longtime professor at Columbia University in the United States and then at the University of California at Berkeley. He chaired NASA's Science Advisory Committee for the Apollo moon landing program. In a 2005 interview, he declared, intelligent design, as one sees it from a scientific point of view, seems to be quite real. This is a very special universe. It's remarkable that it came out just this way. If the laws of physics weren't just the way they are, we couldn't be here at all. Guillermo Gonzalez is an astronomer. His research has been featured in the journals Science, Nature, and on the cover of Scientific American. He's co-author of a major astronomy textbook published by Cambridge University Press. He is co-developer of the idea that there is a galactic habitable zone in our galaxy that is predisposed for the development of life, and Earth just happens to be in it. He thinks there is evidence that our planet was fine-tuned for the existence of life and that it was intelligently designed to make life possible. Marcos Eberlin is a world-renowned chemist at Mackenzie University in Brazil. He's also president of Brazil's Intelligent Design Scientific Society. Dr. Eberlin has written a book titled Foresight that explains how nature is intelligently designed. This book was endorsed not by one, or two, but by 3 Nobel Prize-winning scientists. Not all of those scientists embraced intelligent design themselves, but they thought that his argument and the evidence that he raised were significant enough that they were willing to endorse his book. One of those Nobel laureates then went further a year or two later. His name is Brian Josephson, winner of the Nobel Prize for Physics, a fellow of the Royal Society in England, emeritus professor of physics at Cambridge University. Last year, Josephson endorsed a book on intelligent design by my colleague Stephen Meyer, already mentioned. And in his endorsement, Josephson now stated, "Far from being an unscientific claim, intelligent design is valid science. Scientists and scientific groups that support intelligent design can now be found throughout Europe, now in Italy as well, in South America, in the Middle East, in Asia, in Africa. Articles by intelligent design sympathetic scientists are appearing in mainstream peer-reviewed science journals. One article appeared in 2020 in the Journal of Theoretical Biology, a top journal in the biological sciences. This was co-authored by Professor Ola Höster at Stockholm University, and this article explicitly discusses design and design detection as a way of understanding the fine-tuning of biological systems. I think intelligent design is gaining traction because it helps us make sense of a growing number of things that just don't fit within a paradigm of unintelligent materialism. For example, we now know at the base of life is biological information. We see this in DNA, which functions as a code, directing many aspects of an organism's development, just like software. Codes and information systems are hallmarks of mind, not chance and necessity. Intelligent design also helps us to understand why the universe, to quote Galileo, is written in mathematical language. The fact that we can understand our universe mathematically, the fact that there are mathematical laws underlying the universe, and the fact that we can even make predictions about the material world based on mathematics. Without studying part of the world, you can make predictions and discover new things later that you didn't initially know about using mathematics. This success of mathematics in understanding the world has been a vexing puzzle for the modern materialist. After all, why should there be such a correspondence between math and nature? Why should math and the logic of math underlie nature? To echo Nobel Prize-winning physicist Eugene Wigner, if one assumes a materialist conception of nature, it seems positively unreasonable for mathematics to be so effective in the natural sciences. But it's perfectly reasonable if one sees nature as reflecting intelligent design. Nature is mathematical because it reflects the mind of its maker. Intelligent design also helps us better appreciate the nested layers of purpose in our universe that make our lives possible. One of my friends and colleagues at Discovery Institute is biologist Michael Denton, who lives in Australia. Perhaps more than anyone else, he has helped me understand how intelligent design isn't just found in complex biological adaptations like the molecular machines I showed earlier. It's also seen in countless preconditions in nature, preconditions that are required for us and for our civilization to exist at all. And as I end, I'm going to end on something that I learned through my work with Michael Denton. And it's one particular example that is rather amazing, and I'm not going to do it justice. But it's the existence and use of fire, which almost could be called a miracle. The use of fire is so much part of human culture that most of us probably don't give it a second thought. But the mastery of fire was one of the greatest turning points in human history. So I first want you to understand why it's so important, and then understand the story is just so amazing. It was the mastery of fire that allowed the development of technologies on which our lives depend. In fact, we couldn't be holding this conference. We wouldn't be having any of this technology if we hadn't mastered fire. Fire enabled ceramics, which led to the production of pottery, pipes, and tiles. Fire led to the creation of glass, which produced glassware, windows, plate glass mirrors, eyeglasses, many of us wear. Fire led to the rise of metallurgy, working with metal, which allowed us to transform raw ore containing copper, iron, and other metals into utensils, weapons, tools. Metallurgy, in turn, led to one invention after another: nails, steam turbines, internal combustion engines, automobiles, telegraphs and telephones, computer chips. In short, humanity's mastery of fire was the initial domino. You have dominoes that go up and you push one down, and I should have an animation on that, and then everything follows from it. The mastery of fire was the initial domino that produced a succession of innovations leading to the world we know today. Now, what I've just said about the importance of fire is not especially controversial, but what Michael Denton helped me understand is that the revolutionary impact of fire is that's the end part of the story. In order for our planet to fully realize the life-giving powers of fire, a multitude of precise and exacting preconditions had to be fulfilled in nature. And I'm just going to give a few. If you want more, I've done a documentary on this with Michael Denton, and then he wrote a whole book called Firemaker. But here's just a glimmer. So first, our planet needed the right kind of atmosphere, one that permits both the existence of fire and the existence of a biological creature capable of using it. So it had to have the right kind of atmosphere. But to get the right kind of atmosphere, our planet had to be just the right size, because only planets of the right size can possess an oxygen-rich atmosphere, which is required if you want to have both respiration, animals that breathe, and combustion, which is required for fire. But there's more. In order to harness the most important benefits of fire, our planet needed the right kind of fuel that can generate fires with sufficient heat. Working with iron typically requires heat in excess of 1,200 degrees Celsius. You can't achieve or maintain that sort of heat simply by burning grass or even branches. You need coal or charcoal or something equivalent. But the existence of such fuels depends on the flourishing of large woody plants, and those plants in turn are made possible by a molecule known as lignin. According to Denton, I'm quoting from him now, without lignin there would be no woody plants, no wood, no coal, no charcoal, no fire, no pottery, and certainly no iron, and probably no other metals or metallurgy. But even once you have the right kind of fuel, that's still not enough. You need a living being capable of making and using fire. Fire in nature burns down things, burns down forests, which actually can be beneficial to the ecology of that. But it's not going to get you buildings like this. It's not going to get you clothing. It's not going to get you computers. Fire has to be mastered to be able to use it. And to do that, you need a creature who can do that. But in order to be able to do that, you need a certain type of creature. The living being must have a body of just the right size and design. If you were all the size of ants, before you try to create fire, it's going to burn you up. I mean, if you're an aquatic creature, good luck if you're a dolphin trying to create fire. So you need a being with the right type of body, of the right size and design. You need creatures with muscles of the right strength. And each of these things are far more detailed. I don't have time to go into them. You need a nerve system that can transmit messages to those muscles with the right speed, because even if your muscles are strong enough to deal with what you need to deal with to build fire, if you can't coordinate your limbs by sending messages to them in the speed needed to create fire, not going to happen. But it's not enough to merely have fast nerve conduction. A creature who hopes to utilize fire has to have nerves that are the right diameter. If our nerve fibers were the size of those in invertebrates, for example, our nerve cords couldn't fit inside our bodies. The nerves that we would need to actually transmit the messages in a way so that we could handle things dealing with fire, the fibers would be bigger than our bodies. It wouldn't work. So you actually also have to have nerves of a certain diameter. Finally, you need for the use of fire to result in new technologies, nature has to be seeded beforehand with compounds and elements that have powers that can be unlocked by fire. Not every element there is going to help you build the sort of civilization that we have. Such materials don't have to exist on your planet, but on our planet they do in abundance. According to Denton, it's as if the materials of nature themselves were prepared beforehand to facilitate our technological development. He's not the only one who's had that thought. One of my favorite scientists from history is Alfred Russel Wallace. He actually co-founded the theory of evolution by natural selection with Charles Darwin. But unlike Darwin, Wallace believed that evolution had been guided to produce animals like human beings and to produce a world where humans could flourish. He thought evolution was a very guided process. And so in his book, The World of Life, Wallace wrote extensively about humans' technological development and how much it depends on the fact that our planet was pre-planted with metals like iron and copper. In Wallace's words, without iron and copper, an effective steam engine could not have been constructed. Our whole vast system of machinery could never have come into existence. Wallace pointed out that science is dependent on the natural capacities pre-built into the chemical elements and compounds from which our world is constructed. Consider the chemical compounds that make possible the production of clear glass. In the words of Wallace, without the use of clear glass in bottles, tubes, etc., chemistry could hardly exist. While astronomy could not have advanced beyond the stage to which it had been brought by Copernicus and Kepler. Clear glass, which was made possible through the use of fire, which was made possible by all those other preconditions, clear glass rendered possible the microscope, the telescope, the spectroscope, three instruments without which neither the starry heavens nor the myriads of life forms would have had their inner mysteries laid open to us. Science itself depends on the mastery of fire, which depends upon all of those preconditions. Now, Wallace did not think that the existence on our planet of the materials necessary for modern technology was an accident. According to him, these materials pointed to a cause beyond nature, as he put it, an all-pervading mind. I think intelligent design helps us make sense of the world that actually exists. And by doing so, it not only provides a solid foundation for science, it also inspires us to do better science. Thank you. And thank you to the leaders of the Italian Center for Intelligent Design. May your work be a blessing to both Italy and the world.
That was John West speaking at the launch of the Intelligent Design Center of Italy, an event which took place in Turin, Italy in June 2022. Stay connected to continuing news and developments in the world of intelligent design by following ID the Future on your podcast app of choice. And as you're doing that, please give it a 5-star rating. It really helps us get the word out. For ID the Future, I'm Tom Gilson. Thank you for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.